Section 9.1 talks about different ways to classify triangles. You can classify them by their angles and by their sides. Okay, so by angles and sides. So think of some ways that we can classify triangles by their angles. Name the different types of triangles. Any ideas?
No.
Okay. There are acute angles. That is when every angle is less than 90 degrees. What about obtuse? New notes packet. That's when 1 is greater than 90. We also have right triangles, where 1 is exactly 90 degrees. We also have one where all of the angles are equal to one another, which would be 60 degrees for each angle, and that is called equiangular. And that is when all are 60 degrees. When we classify angles by their sides, there's scaling, isosceles, and equilateral. Scaling is when all of the sides are different lengths. Isosceles is when 2 are equal lengths. And equilateral is when all are equal lengths.
What is DC?
Equiangular. All are 60 degrees.
How do you spell
EQUIANGULAR. So let's try to label these by whatever way we can. So each of these images. So for this first one, what type of triangle is that? Scaling. and also acute. Because all the angles are less than 90. What about the next one? I've only got one way to describe this because of that right there.
Right triangle.
It is a right triangle. Good. What about the next one? Obtuse. What about that one? Mm-hmm. All of the angles are the same. Equiangular. We're just gonna try to keep on going. What about this bottom left one? It doesn't show anything. This one's actually going to be scaling. It doesn't say anything about the angles, but it also doesn't show that any of these side lengths are the same. For this one, there are two sides that are equal, so it's isosceles. And all three sides are the same, so that's an equilateral. Is this stuff making sense so far? With your angles and sides? Okay. So looking at the angles, what do you notice? Right angle, good. Oops. What about the sides? Are any of them the same? They're all different side lengths, so this is scaling. What about angles for number 2? What do you notice? Yeah, there's one really big one, which means it's obtuse. Do you notice anything about the sides? 2 are equal, so this means it is an isosceles. Is this stuff kind of ringing a bell? Have you seen some of this stuff before?